The Leminscate is the last type of graph. It's a little bit different of an equation, and you're either going to have it be diagonal or horizontal depending on the sine or cosine. So in this case, we're working with the equation r squared equals a squared sine of 2 theta. Sine will be on the diagonal, cosine will be on the horizontal. It's kind of like a rose curve, except you're just going to be figuring out more like a propeller length, not a petal length. So a in this case will square root the 16, because that's in the spot of a squared, so a is going to be 4. That's your distance for your petal. Critical points are going to be 0, 0. And then the sine graph is going to go on the diagonal out 4. 1, 2, 3, 4, and here. And then you're just going to sketch in you can call them petals or propellers, however you want to look at it, since there's only 2. Key here is making sure that you square root. Obviously, if you don't, it will not fit on the graph. There's occasionally times where I put something that doesn't quite fit on the graph, but obviously 16 would not. So that would be your graph for 16 sine of 2 theta. And then the Leminscate for cosine is just going to be on the horizontal axis. So let's take a look at that one. Same idea, r squared equals a squared cosine of 2 theta. So in this case, a is going to be 5. And you'll go through 0, 0 and sketch in 2 petals. So 0, 0, 5, 0, and you can either do negative 5, 0 or 5 pi. And there are multiple ways to label these points. And that's the Leminscate. Should be fairly easy as long as you're able to distinguish between the cosine and the sine graph. The last type of graph, which is the spiral of Archimedes, you just need to know about the distance between the spirals and how they get spread out or condensed down, and that you will use your polar investigation to study for the quiz and for the test for this.